get with multiplying radicals. So when you're multiplying radicals, what you're going to do to simplify, you're going to make sure, so we're going to get a couple of rules here. So the first rule, make sure indexes are the same. So those roots outside need to be the same. All right, the second thing, if they are, multiply all numbers. Okay? The last thing we want to do, well, the third thing we want to do, multiply all variables. And then and only then can you do what you need to do, which is to simplify radicals. All right? So first thing we want to do, make sure the indexes are the same. Indexes for number 1 are exactly the same, right? So we're going to do number 1. We're going to do number 2. I think we're going to do all of these. So indexes are the same. So I'm going to rewrite this. The cube root of 250 times 5. So I'm going to go to my graphing calculator here and go to second mode or the home screen. 250 times 5. Enter. That equals 1,250. So I'm going to rewrite this. This equals the cube root of 1,250. So when I go to y1, I'm going to put in 1250 over x cubed and look for that smallest y value, smallest whole number y value. So 50 over x cubed, second graph, smallest y1 looks like 10, which is paired to 5, and smallest y1 is going to be the 10. So 5 cube root of 10 simplified. So this equals 5 cube root of 10 as a simplified form of that. All right, what about number 2? Well, we're going to multiply these two numbers, and then we're going to multiply these two numbers and simplify. So I have 18 square root of 18 square root of 28 times 11. So graphing calculator here, second mode. 28 times 11. And I get 308 inside of the radical. So when I go to simplify this, I'm going to put in 308 divided by x squared into y1. So y1, 308 divided by x to that index, which is 2, second graph. Smallest value here looks like 77. And it's true, smallest whole number is 77. So this equals 18 times 2 square root of 77, or 36 square root of 77. For the next one, I'm multiplying all these numbers inside. So 14 times 4 times 14. So second mode. And I'm just going to go ahead and put it in my y1 when I find a number. 14. That equals 784. So I go to y1, 784. Second table. And it looks like 14 and 4. But I'm just going to make sure and just go down and check. And looks like 28 and 1. So this is a perfect square. This is our first perfect square. So we have this equals the square root of 784. This equals the square root of 28. 28 times the square root of 1. or just 28. This is a perfect square. Perfect square. All right. Now, number 4. Remember what I said? Multiply what's outside first. So 5 times negative 3. 5 times negative 3 is negative 15. Inside, I have 1x. So 1x. For my y's, I have 1y and then 4 y's. So y to the 4th. And for my z's, I have z squared. So if I rewrite this, I have negative 15 square root of x, or we could rewrite that with the fractions, x to the 1 over 2, y to the 4 over 2, and z to the 2 over 2. So that's z with a line through it. So simplifying, I can't do anything to that x. It's going to produce an odd number. So it's going to stay inside of the radical. So negative 15 x to the 1/2. I'm just going to write it like that and then go back. Y squared, 4 divided by 2 is squared. Z to the 1 power. So I have 15. These things go to the front, remember. Y squared, z to the 1 power times the square root. This reverts back to the radical form of x. For the next one, you be careful. So we're multiplying this times that. So that means I have the square root of negative 3 times 24 minus the square root of negative 3 times negative 6. Okay, simplifying, I get square root of negative 3 times 24 equals the square root of negative 72. Minus the square root of negative 3 times negative 6 is 18. Now, I have two things to do in y1. So first I'm going to say y1 equals 72 over x squared, right? And I'm just going to bring that negative out, or the I out here, times that. And let's go evaluate that. So I have 72, looking for the smallest y. And looks like the smallest y is 2. So 2 is paired with 6. 2 is paired with 6. So that gives me 6 square root of 2. Okay, and now 18. 18. It's not a complex number, that 18. Divided by x squared, second graph, and it's 3 square root of 2. So minus 3 square root of 2. So I'm going to rewrite things here. Put the number first. Have 6i square root of 2 minus 3 square root of 2. So looking at the next one, we want to be cautious. We want to be careful. So 1 times 2. So we're using the FOIL method. This is F. Front. F means front. O means outer. I means inner. L means last. All right. So 1 times 2 is 2. And then for my outers, that's 1 and square root of 5. So minus 1 square root of 5. For my inners, that's negative square root of 5 and 2. So minus 2 square root of 5. And then my last parts right here. Square root of 5 times square root of 5 is positive 5. Now, I'm combining my like terms here. I get 2 plus 5. And negative 1 minus 2, we're going to do this in the next unit. Negative 3 square root of 5. And my answer is 7 equals 7 minus 3 square root of 5. So this is a next lesson type of thing right here. So no worries on that. Now, the next part is division or dividing radicals into simplest radical form. The roots must be the same. The indexes must be the same. And you may separate everything, or you may combine numbers inside of the radical. Then you reduce to evaluate. So I like to see if the fraction can be reduced. If it can, reduce the radical and then evaluate. If it cannot, check to see if the individual parts can be evaluated via the radical. So a lot of words there, but the indexes need to be the same. So can this be reduced? I don't know. But I like to separate parts. Separate parts if it can't be reduced. Okay, separate parts if it can't be reduced. That means I have the square root of 3 over the square root of 4. I know that the square root of 3 does not reduce anything. However, the square root of 4 does. And my final answer is this. Okay? For number 8, I can't reduce 2 and 7. I can combine these two and reduce. So what I'm going to do is have 2 over 7 times the square root of 45. Sorry, that's a negative 45. The square root of negative 45 over negative 36. So what I'm going to do, I know that 9 divides out of both terms. I'm going to go to my graphing calculator and make sure that I can't reduce that fraction any further. So I'll press alpha y equals, put negative 45 over a negative 36. This helps me get rid of that negative. Who wants to deal with a complex number with all of that going on? Simplifies to 5 over 4. Okay, so this equals 2 over 7 times the square root of 5 over 4. So you could keep it like that, or you could write 2 square root of 5 over 7 square root of 4. Either one works. Either one works, okay? Number 6, gonna rewrite this. I get 6 times the square root of, similar to what we did previously, okay? Now, that negative is just negative. So I'm gonna go ahead and bring it out and make it an I. So this becomes 6i times 40 over 28. Okay. And I'm going to go to my graphing calculator, see if it reduces. So alpha y equals, enter 40 over 28. Get 10 over 7. Can't reduce it any further, so I have 6i square root of 10 over 7. You could also write 6i square root of 10 divided by square root of 7. But preferably, this looks the best. Last part, you're going to be using the quadratic formula to solve these problems. Let me go back. Right? So you have 13, 14, 15. And I will do number 10 and I think number 15 with you. So remember the quadratic formula. It's where you have x equals negative b plus or minus the square root of b squared minus 4 times ac and divided by 2a. So first we need to figure out what a is, b, and c. And just make sure that it's in standard form. Make sure it's in standard form. Make sure all the terms are on one side of the equal sign. So a in this problem is 1, b is 3, c is negative 4. So I'm going to plug these numbers in. This equals negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 4 divided by 2 times 1. This equals negative 3 plus or minus the square root of 9 plus 16 divided by 2. Simplifying, you should always get two different answers. So here I get negative 3 plus or minus the square root of 25 over 2. This equals negative 3 plus 5 divided by 2 and negative 3 minus 5 divided by 2. And this, remember, square root of 25 is 5, right? That's where I got the 5 from. Simplifying, I get 1 comma negative 4. So my two answers here, x equals 1 comma negative 4. That's my final answers there. So you should be able to do 11 and 12. I do want to do 13. So 13, 15 are similar because they're not on the same side. But rewriting, the only thing I need to move, the easiest thing to move is this 11. And I get plus 9x, and it becomes negative 11. And I have a 0 on the other side. So A equals 1, B equals 9, C equals negative 11. When I write this in the formula, x equals negative b, which is 9, plus or minus the square root of 9 squared minus 4 times 1 times negative 11 divided by 2 times 1, or negative 9 plus or minus what's inside of that radical, 9 squared minus 44. So I'm just going to use that. I'm just going to put it in my calculator here. 9 squared minus 4 times 1 times negative 11. Make sure I'm adding that. Yeah. So inside I have 125 divided by, and yes, you do need to simplify this radical. So 125, go to y1, 125 divided by x squared. Second table, and I get 5 square root of 5. So this simplifies to negative 9 plus or minus 5 square root of 5 divided by 2. And this becomes two different answers. I have two different x values. I have x equals, curly bracket, negative 9 plus 5 square root of 5 divided by 2, comma, negative 9 minus 5 square root of 5 divided by 2. Okay? So finish that up. I'm going to do this part, this portion, during the next class, right? And what I need you to do tonight is go through and do some homework. So I'm asking you to do, for your homework, the very first page. So 1 through 14. 1 through 14. And that page, I will let you know what that page number is. So the very first page, there's two parts to this homework. I only want you to do the very first page. Okay? So have a great day. That did take pretty much all of the class. If you didn't finish this, you definitely need to go back and look at that